What's up, everyone? My name is Dr. Chris Hacks, and today we're going to be doing the CryptoPals Crypto Challenge, Challenge 13, the ECB cut and paste. So today we're going to be writing a key value pair parsing routine that would take like a structured cookie and do all this stuff. Basically, let's skip past this a little bit. What we're going to be doing is we're going to be taking an email and creating a user profile that looks something like this. Okay, the user profile will be encoded by our profile4 function, and then what will happen is we'll get something like this, but it'll be encoded. It'll be in AES 128. We'll just get some, random ciphertext that we can't understand. And what we're going to do, and then also we could pass that ciphertext back into like a decrypt function that will give us our user profile. However, what we're going to do is we're going to break that. So this way of storing data where we have it's like a key value pair, so that we have the key foo and the value bar, and then we have like this ampersand to differentiate between two different pairs. What we're going to be doing is we're going to be breaking it. So let's say, for example, you could pass in some like foo bar and role equals admin. We're not going to allow anything like that to happen. Our function, the profile4, will eat that. It will eat the ampersands and it'll eat the equal sign. So we can't do something like that. So we're going to attack this. And the way we're going to do that is with some clever lining up of the blocks, but I'll show you all how to do that. So let's just get this set up so that we can go ahead and dive into the attack. The first things we're going to need to do, though, is we're going to have to implement the parsing routine, the profile4, and the decryption. So let's just jump into our code, and we will do that first, okay? So I have challenge 13 right here with all of our instructions. And the first thing I want to do is I want to actually create like a parse KV, parse key value sort of function. So let's do that first, okay? So I'm going to go into encoding-utils.h, and we're going to add the thing here. So I'm going to use a map. I'm not going to create like a JSON object or anything like that, like we would do in JavaScript. Instead, we're going to create just a simple map, simple hash table, dictionary, whatever you want to call it. And we're going to use that. So we'll create a map, and we're going to have parse key value. Or let's call it KV for short. Parse key value. Constant, standard, string, reference, input. Okay, so here we go. I'll make sure to include map. To include map. Perfect. Alright, so here is our signature. Let's jump into encoding-utils.cpp, paste that, and we'll go ahead and implement it. Alright, so the way I'm going to do this is like so. So standard map, get a string. We're not going to get this too complicated. We'll just iterate over all of our characters in our input string, and we're going to look for the ampersand, we're going to look for the equal sign, and then parse it that way. So we'll do it like this, like so. Have size t. We'll get a little pointer going here. This will be pointing to the character that we're looking at, and then basically while our pointer is less than the size, we can keep going. So that would be like we're pointing at like character 0, for example. Alright, so size t. We're going to need the ampersand position. So the way we'll do that is like so. So we'll call it like ampersand position. That should be good. And we're going to do input.find the ampersand, and we'll pass in our pointer so that we know where to start. And we'll do it like this so that we can find our ampersand, and we'll look at everything before it to get our key value pair. So string, if it's the no position, like then we'll just put it at the end. That way we know that we've reached the end of our string to parse. All right, so let's get our chunk of data. So we're going to have standard string chunk, and that's just going to be a substring. What we're going to do is we're going to start wherever we're at. So we'll start at p, and we'll do ampersand minus p. That will give us the data from wherever our pointer is pointing, the start of our chunk to wherever the ampersand is minus our pointer. Okay. Then we can parse that chunk of data. So size t will get the equal sign. It's just going to be chunk.find. We'll get the equal sign passed in there. If the equal position is not equal to no position, oops, not equal to standard string no position, then we actually have some meaningful data that we can parse. So standard string, the key will be everything before the equal position. So chunk.substring 0 to the equal positions point. And then our value, standard string value, is just going to be everything after that. So chunk.substring equal position plus 1. That'll give us everything after the equal position, the equal sign position. Okay, and then we can add that to our map, right? So key value is just going to be the key, and we'll pass in the value, like so. Like so. Okay. And then we also have to increment our position. So we're going to just set it to wherever the last ampersand is. So p equals ampersand. So the ampersand position will be our new pointer position, and we can get everything after that. And we'll do this until we hit the end of the string. That will give us all of our key values, and then we just return our map, and plain and simple like so. All right. So next up, we are going to want to get our profile 4, right? So let's get profile 4 up and running. Yeah, so I'm going to put that one in here, so we'll do it like this. So standard string profile 4, we'll just pass in a constant string email. Okay. Once we have our profile 4, first things first, we want to sanitize it. So I'm going to do it like this. Standard string, let's call it clean email. And what it will be is like 4 character C in email. We're just going to do if the character is equal to an ampersand, or the character is equal to the equal sign, then we'll skip it. So we'll just do continue for. Continue. Okay. Otherwise, make sure I do this. If C is equal, okay. So yeah, we'll just continue. Otherwise, we'll just do clean email.push back C, like so. That will get rid of any of the ampersands or any of the equal signs. We could like put them in quotes, but I'm not going to do anything like that. We'll just get rid of them. So that'll get us sanitized. Once we do that, we'll need to actually get our email. So what I'll do is I'll do standard. Actually, wait, hold on. How do I want to do this? We need to encrypt it. So what we'll do, yeah, so we'll do standard string encrypt is equal to, I'll call it ciphertext. Ciphertext equals this. So we'll do AES underscore 128. We'll get ECB encrypt. We're going to pass in this. For our first parameter, email equals plus clean email plus, and then just for like proof of concept, we're just going to make it user ID equals 10 and role equals user, just like that. I mean, in real life, you wouldn't see it like this. It would be like this would increment every time there's a new profile, and like this is going to have some function to check it. But this is just proof of concept, so this should be good enough. And we need to pass in a key. So let me also get a key here. So constant standard string key equals generate random bytes, and we need 16 of those. So there's our key. Okay, perfect. So there's our ciphertext. Actually, I really don't even need a variable to hold it. Let's just return this. And then also, let me go here, F12, I believe. Yeah, let me make sure. So are we padding it? Yeah, we're already padding it ourselves here. Therefore, I'm not going to need to pad it here. So we should be good. All right, so that's profile 4. That'll encrypt it. And then basically, let's also get a decrypt function going. So standard string decrypt. Or no, this wouldn't be a string. This would be a map. So standard map would be string, comma, standard string. And we'll do decrypt profile. Yeah, that should be fine. I'm just using profile _4 because that's what they gave us. Yeah. Okay. Constant standard string reference ciphertext. And what we'll do here is we're just going to do standard string AES _128 ECB decrypt. We'll pass in our ciphertext and our key. And then, wait, what's wrong here? It wants, oh, duh, I need to actually get variable name, so we'll call it like decrypted. There we go. Okay. And then if I come into here, as we can see, we are calling unpad at the end. So we shouldn't need to unpad it ourselves, hopefully. All right, so now that we have that, we can just return parse kv, and then we just pass in our decrypt. Okay, so those are our two helper functions, basically. Now we can actually go ahead and carry out the full attack. All right, so here's basically how the attack's going to work. Because of our last challenge, we know how to decrypt anything in, what was it, ECB mode or CBC? Let's see. Yeah, ECB mode. So challenge 12, we decrypted ECB. So in real life, they're probably not going to give you a decrypt profile function. Maybe not. They might not give it to you, which is probably safer. But either way, this is a flawed way of encoding data, at least safely. So what we're going to do instead is we're going to assume that we have the decrypt function. And for our attack, we're going to do two things. We're going to make like a normal profile that will be aligned properly so that it takes up exactly two blocks worth of data. And then we're going to create a malicious profile and pad it in a very, very specific way, and then combine the two profiles in order to get what we want. So because of our last challenge, we can find the block size. So let's say we already know that the block size is 16 bytes, which we already know. Okay. So the first thing we're going to do is we're just going to make a generic normal email profile. Let's actually take a look at this here. So let's say we already did some recon, and we already figured out that this is the string that we get back. We already figured out that it's eating these characters, okay? So we did some recon, and we know that this is this. So let's count. We have 1, 2, 3, 4, 5, 6 characters here, and then we have, so I can just look at it. So there's 17 characters here for a total of 23 characters, or 23 bytes that we actually care about. Okay? So let's do a little bit of math. So 23, so let's get 2 blocks. 2 blocks is 32. So 32 minus 23, that's 9. Okay? Let me just make sure I did that right. Oh wait, we don't want to count the user. I'm sorry, I forgot. We want to get rid of this user part. The reason why we want to get rid of the user part is because we want to put admin here. So we're going to line up the block correctly so that we have this be the end, and then this starts in the third block. Okay, so let's recount. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so because we're getting rid of 13. Sorry. Because we're getting rid of user, that subtracts 4 characters. So instead of 23, we actually have 9 19 in total. So we have 6 here, and then we have 13 here. That's 19. 32 minus 19 is 13. That means we want an email size of exactly 13 characters, okay? The reason why we're going to do that is that's going to push this into a different block, and then we can manipulate it to how we want it. Because remember, ECB mode will encode certain blocks all the same with the same data passed in. So let's go ahead and do that. So first things first, let's do standard string normal email, and let's assume there is some email validation. We could just pass in, 1, 2, 3, 4, all the way up to 13 characters, but let's assume there is a little bit validation. So I'm going to do this. Let's do at test.com. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters right there. Okay, so we have 9 characters right here. So we need another, let's see, we said we wanted what? 13 characters, so that means we need another 4. So I'm going to put 1, 2, 3, 4 A's. So we have 13 characters right here, okay? Alright, so here's our quote-unquote normal email, and let's get it. So here's our normal cipher. So standard string, actually I don't want to follow snake case. Nobody likes snake case. We'll use camel case. Okay, we'll do normal cipher text equals encrypt profile. What did I call it? I called it, no, it's just profile 4. We don't have an encrypt profile function. So profile 4, we'll pass in normal email, and we get our ciphertext back, okay? And then I'm going to go ahead and I'm actually going to split this into blocks. And this will be useful later when we are trying to do our lining up. So standard vector string, and we'll call it normal blocks. And we'll just use a split block function. Split block, normal ciphertext, and we know that the block size is 16. Alright, so that will give us 3 blocks because we have 1 block that includes our email and our normal email, and then another block that includes the other part of our email and some metadata, and then it gets split right here, and user is in a 3rd block by itself. Alright, now we basically want to create a encrypted block that corresponds to admin. So I guess this would only work if there is no email validation. If there was, we might have to do a couple extra steps to line up the word admin exactly where we wanted it. It would have to be at the very beginning, and then we would put like admin at whatever and then pad it a certain way. But either way, I digress. We are going to assume there's no email validation. So here's what we're going to do. We have a string, and we'll just call it admin, okay? And it contains the word admin. This is like our payload, more or less. We're going to try to make sure that this gets inserted as the 3rd block, which is exactly where we want it. So in order to do that, we have to actually pad this. So I'm going to say admin, let's do this, string, standard string, admin, padded. Okay, admin padded is just going to be pad pk cs7, and we're going to pad this on purpose because we want it to be padded correctly before we insert it into our profile 4 function. That's going to be 16. Okay. So now what that's going to do is that's going to pad admin, and because admin is 5 characters long, it's going to pad it with 11, so 0x0b at the end. It's going to make 11 of those. Okay, and that's what we want. So if we get a block, an exact block, we can take the 2 first blocks from normal blocks, and then put admin padded, whatever this returns, as a block. Okay, and it'll work properly. So now we have to make sure we get this into the right block. If we take a look at our profile 4, we're going to get email equals admin, which is not what we want. So we have to make email, we have to fill this clean email up with a bunch of junk, okay? And then put admin at the end. So this is actually how we would do this. This makes sense. So let's say, for example, admin's just part of the domain name. So I was wrong. We can actually do this with some email encryption. So let's do this. Let me show you what I mean. So let's say we have standard string, and I'm going to call this attacker email. And what we'll do is we need 10 characters because email is 6 characters long. If we add another 10, that will put this in the first block, and then this will be the second block, which is what we would like. So I'm gonna make a fake email. So let's do something like this. We'll do like @test.com again, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So we'll just add an A at the front to make it 10. So this attacker email is now 10 characters long, so that pushes admin into the next block. So I put admin padded. Oops. Yeah, admin padded, like that. And then there's our attacker email. And if this was doing some like simple like regex type validation where it's looking for like an ampersand, or I'm sorry, like one character here and then an @ and then like one character here and then a period and then some sort of domain, this would work because you can get emails from like weird things like say we get like proton.me, right? You get an email at proton email, then it will do some weird stuff in the top level domain. So a real email checking function probably wouldn't be able to get like too complicated with this. So if we have a little bit extra at the end, it probably won't be able to filter that out. So that's how this would work. Okay. Now let's go ahead and actually encrypt this. So the attacker email is all set up. So we will do string attacker ciphertext equals profile4, and I'm going to pass in our attacker email. Okay. And then we'll do standard vector. I'll just copy it from up here. And we're going to put attacker blocks equals split blocks attacker ciphertext, and we know it's size 16. All right, now we can actually build what we would like. So up until now, we got 2 profiles back. So we have the attacker ciphertext and the normal. If we were to decrypt these, the normal one would just be the email plus all this stuff, and the attacker one would be the email plus all this stuff. However, we have the blocks exactly where we want them. So now we can build our forged ciphertext. So I'm going to do this. I'm going to do string forged cipher text is equal to this. So all we need is normal blocks 1 and 2. Normal blocks. We need block number 1, or the first block, which is block 0. We need the second block, which is block 1. Okay, so we get the email, and then we also get the user ID and all that stuff. So whatever email we put in here, I mean, you can put your own email or whatever you want. It just has to be the right size. But here, if we were to get the third block, it would include this user right here. However, we don't want that. So instead, we're going to get the admin block. So I'll do it like this, plus attacker blocks. And we need, it's going to be the second block in that, because the first block is email plus all the padding we added, and then the second is going to be admin plus all the other padding, the PK7 padding. Okay, so this will give us our forged ciphertext. So now let's actually go ahead and decrypt this. So I'm going to say we're going to need a map. So standard map, standard string, comma, standard string profile equals decrypt profile, and we'll pass in our forged ciphertext. And then let me go ahead and build an output string. So standard string output, and what I'll do is I'll just do this. This should only be 4 blocks big, so 64 bytes. So, or I know this is going to be the decrypt. So it shouldn't be a big deal if I do it this way. But what I'll do is for const auto each key value pair in profile, we're going to get output plus equals pair. Yeah, that's right. Pair dot first plus. I'll use an equal sign. Let me check what they used in CryptoPals. In CryptoPals, they used. Let me pull that up real quick. They used. Oh yeah, they used this. So they'll use the colon. All right, so I'll do it that way. Colon, and then I'll have a little space after it. Plus pair dot second. Let me make sure output's actually initialized first, so don't scream at me. Alright. What's it mad about? Output, because I spelled it wrong. That's why it's mad. Okay, pair.second. And then I'll also include a new line character so that everything's on a new line. And then we just go ahead and return output. And if all went well, and I think this is how we're going to do it, let's try running it and see what happens. So crossing our fingers, everything runs smoothly, and we actually get what we would like back. Let's see what it does. Generating code. Okay. Loading. Oh. Did it work correctly? I don't see any output. Okay, hold on. Let me make sure that I actually loaded this up correctly. It could be in an infinite loop. It could be, pretty sure I have the main set up correctly. Challenge 13. We have challenge 13 right here. Yeah, it looks like it's in an infinite loop. Let's, yeah, I want to do a little bit of debugging and see what went wrong, because I'm assuming probably either the parsing function or something else is, not working correctly. So let's see. Let's put a breakpoint there. I'm also going to put a breakpoint here on challenge 13 so we can step through this. So I'll let you guys actually see. Hold on, I messed up. I closed the window by accident. All right, let me move this terminal window off to the side real quick. All right, so let's go through this. All right, so that's all set up. Looks good, looks good. So it looks like profile 4 is working correctly. We're getting some good ciphertext here. All right, here's the parse KV function. Let's make sure that this is working. Okay, so it looks like we got. Ooh, that's what's that like -v character at the end there? Is that padding or? Looks like our unpad is not working correctly. So I'm gonna do a little debugging into that and figure out what is going on. I'll be back in a minute. Alright everyone, so after a little bit of debugging, here's what went wrong. Basically our parse KV function did get stuck in an infinite loop. All we have to do is add this line. We had it was p equals ampersand position. You gotta increment it by 1, so we move 1 past ampersand, of course. So silly mistake there, but that's all that needs to change. And then also I did notice something while testing. If you run it now, what you'll see, let me get rid of the breakpoints first. What you'll see is you get all of this extra space. The reason why, admin's still padded. We had to pad it earlier so that we could get the correct block size. Now we got to unpad it. So what I'll do here is just this. Pair.second. So I could either do it here in this, or I could do it in the decrypt profile. Because we don't have access to the decrypt profile as the users, I'll do it here. So pair.second. And we'll just do PKCS7, or I need it, unpad. Yeah. Like so. So now, let me make sure I get the right thing. PKCS7, there it is. Perfect. Alright, so now if we run this again, as we can see, yeah, we get everything back correctly. So we get email, and then test, and then admin, UID 10. So yeah, that's the whole attack. There might be some ways to unpad it, because like admin might be weird. The system might not recognize it if it is padded. So there's a couple of workarounds. It just depends on how the server that we're attacking is set up. But this is the general idea for the attack. So hopefully y'all found it useful. Hopefully y'all learned something. Thank you all for watching, and I'll see you all in the next video.